So, good day. I am Winson, BSCS F3 under J Serato. So, today I will be explaining my code here, the lesson activity link, activity tree linked list. And in this linked list, we have a node that has a element and has a node pointer to the next node. So, in this video, I will be explaining what's the functions that we have asked to implement. And we will be starting first at the end add, which basically will add the number that will be inputted in our parameter function to the last node. So if you will be adding a 60, it will be, and you have already 5 nodes, of course, it will be added to the last one, which is depending on the value of the number. It will be ranked depending on the value of the number because we are using a sorting algorithm based in our nodes here. So in this one, and add, which basically add the number to the last, uh, we are just using our add tail function that we have called in our previous slide, and after that one we'll be returning the index because this is the last value of our tail, and that that means that we have satisfied the condition here with which will return the last value of our a function that will return the last value of our index of our linked list. So in the add tail, what we have implemented here in our add tail, we have created a new node and this set the element to the number that we have called our function on num. So this will be, for example, 20. We will be creating a new node which has a value of 20 and the tail. If the tail is not node, which means we already have a tail, we will be setting our tail next, which, like, for example, this would be the box here. This is the tail next, and the tail next we will be setting that one to our newest. So this would be the last one, and the crown we will be setting the crown to the newest. So the value tail here we will be setting that one to the newest. So that means our newest tail will be the newest, and this would be already the previous tail. I mean the previous function that we have a reference to our tail, which is the newest. And if that's so, if the head our is null, which means if we don't have any head yet, that means that we have this is only our first value here. This is our first initialization here. We'll be setting our head to the newest, which basically means our head is our newest and our tail is our newest. So right, and after that one, the end remove function here in our linked list. This would basically return. Okay, this would basically return the position of the removed element. So whenever we encoded a number here, for example, 40, um, it will search for the entire array, and if the element is equal to the number, of course, we will be getting the position of that node, and then we will be returning the number. So the first thing that we did here was to we will just be skipping this one because we have just set our current node to our head so that we would be able to store our data and to traverse in our array using this one here. But we will just skip in this one. So what we did here in the um, while iteration here is that as long as the current node is not equal to null, which means that we are not yet at the end, we will be first adding our position because that means that if we have iterated one here, that means that we are in the first position. And if our element is equal to our number, of course, we will be doing the function, we will be doing our algorithm here, which will remove that element and will also remove the element and also clear the clear the node, and Yeah, that one. So if the current node is equal to the element, what we will do here is first we will scan if the previous node is not equal to null, which means that if the previous node is not equal to null, is not equal to null, that means that we are still in I mean we are already in our second iteration, because if the previous node is equal to null, that means that we are still in our first iteration, because at the end, if we have gone to our next iteration, our previous node will become our current node, and our current node will be the next node, which will be the second position. So for example here, if the previous node is not already equal to null, um, we will be we will be setting our previous node is equal to next, which basically means that our previous node, which is the next one. So that means that our this was like the current node. This is the second position. So we are setting our second position. I mean, no, we are setting the next, which is the tail of our first position before our current position. So this is the previous position next. We will be setting that one in our current next, which is basically like there is a box here which will be the current, and we are pointing this one here so that this current here will be removed. And after that one, depending on the process here, I will just explain this one after. The previous next, we are pointing this one to our current node next, which will skip the current node here. For example, this is the current node. We will be skipping this current node here, and we're pointing our previous node, which is the previous node, to our current next node. So after that one, if our current node is oh wait, after that one, if depending on the case here, we will be freeing our current node. So before that one, if our current node is equal to tail, which means that we cannot already found our current node next here, because it will be already it will be equal to null. We will be setting our tail to the previous node, which is our previous node is our current node. I mean, is the node that is currently in the next node, which is basically after we free this current node, because we are skipping this node as what I have mentioned. So our previous node is our current next node, which will be the next node, which will be the next node of the number that we remove. So that is the idea of our remove and remove function. Is there any pause button here? Oh, I guess we don't have any pause button. Hi. So in our get, this would just get the position of our node of our linked list. So what we did here, we have just, as usual, we have just created our node is equal to head, so that we would be able to traverse and count, which basically return our which will return the element, the first element that is equal to the, I mean, okay, I see. So in this position, we will just be in size, okay, in size, and then so what we did here in our end position is that we will be returning the value of the element in that position. So the first thing that we did here was to, of course, we have created a new node and set our count is equal to 0, so I will just be explaining that one later. So the first thing that we did here was, as long as the node is not equal to null, or this should be fine if we did like this, but I did this one so that it will be more readable. As long as our current node is not equal to null here, we'll be adding a count, which means that this is the current position. And if we are in that current position, if since we are iterating in all our list here, if the current position is equal to, so this is our current position. If our current position is equal to the position that we are wanting the element to return in, so of course we will just be returning that the value of that position. Yeah, we will just be returning the value of our position. Else, if that would be not true, we will just be traversing to the next position. So that is the basic idea of get. We're just traversing and then returning if the position is equal to count, which means that we are already in the right position, and then returning the element, the value of the element in that position. And if not, we will just be traversing in the next position. So in size, so you just get the size because we are just returning the index here. And also we're moving up to the next function, which is the remove at the remove at function, we'll just be giving the position of the node which we want to remove, the node which we want to remove that node in our linked list. So in our remove at function here, of course, we have constraints here. So our constraints here is that if we have given a position which is less than or greater less than 1, which basically means 0. If you have a position 0, of course in our linked list we don't have a position 0. So if our position is less than 1, of course it will return 1, as well as if our position is greater than index, which basically we don't have a position which is greater than index because that would return, that is false, so we will return -1. And in this one element, I will just be skipping this one. I will be explaining this one later. Oh, yeah, okay. So of course, if our position is equal to 1, which means that since our function here is remove at, so if our position is equal to 1, which that means that we will just be removing our head. So that's basically it. So if our position 1, we will just be removing head, and as what I have mentioned, remove head here function will remove the head. It will create a new element, set that element next to the head next, and then setting the head to the current element. Setting the head to the new element that we have pointed, and then yeah, that should be good. So there are also cases like if that would be the if our if our tail is equal to null, of course we will also be setting our tail to our newest. So in our remove head here. So of course if position is equal to 1, we will be removing the head, and we will return the element which is basically the head here. The element is the head element. So in the next part, of course, if any of those constraints are false, and we have proceed to the next one. So what we'll be doing here, if our current position, first is we have just initialized our counter so that we would be able to check out which position we are already. And for this one, since we will be iterating to our function, to our linked list, whenever we will do this, we will traverse to the whenever we will done this one, we will go to our next function, our next node by setting the current node is equal to current next. So we will just be going next to the next to the next. So what we can do here is that since our counter is equal to 1 here, our position will become added here. For example, like this, we can just set this 1++ first and then setting this 1 to 0. But I prefer to use this one because it will be more logical. So if it will be more readable. So if our counter is equal to the position -1, which is basically we are already in the second position, because if we are in the first position, of course, the position 1 here would become true and it will return the element. So of course we are in the second position already here. So if our counter, which is equal to 1, of course we are in the second position, we are creating our temporary node and we will be setting that temporary node to our current next, which means that this is the third position, and we are setting our second position to our third position. So that means that this value here was already holding this value here, which is our second position. The temporary is already holding our second position, and while it is true that our value is holding the second position, um, the second position we will be setting that one to our temp next, which is basically the third position because we are setting this one to our second position. So temp next would be the third position. And since we want to remove the second position, we will be freeing that one after. But before we free that one, there is a case here that if the element of our temporary, which means that the element of the node that we want to remove is equal to the tail element, which basically means that the element is equal to the tail. I mean, the node is equal to the tail because the element value of the temporary is equal to the tail. We'll be setting our tail to the current. We'll be setting our tail to the current node, which is basically the our current node is okay. So which basically means our tail is equal to the current mode. Our current mode is equal to the position that yeah, position of the previous position. So our current mode is equal to the previous position. So that means if that was true there, we'll be freeing our temporary node, which is the next position, because our temporary node is set up to the next position here, which is the the position that we want to remove. So that's basically it. So for our remove all function, so in our remove all function, it will just remove all the number that that has a value equal to our. It will just remove all the node that has a value equal to the number that we have set in our parameter. So for example, if we have a node 10, 10, 30, and we want to remove, we will input the number 10. Of course, after the function will after we call the function, it will only return 20, and we have removed all the nodes that has an equal number of the number that we have inserted in that position, which is the 10. So in our removal function, if the index is equal to 0, of course, we don't have any value of our index, and we don't have a value in our node, in our linked list, it will return 0. And we have also created a counter here, which I will be explained later. So while the head is equal to the element is equal to, while head element is equal to number, of course, if there are cases like in our notepad here, let me just explain that one. 10, 10, 10, 20. So in our case here, while the head element is equal to the number, we will remove head and counter plus plus, which means that this is the value. This is the counter. I mean, these are already in the counts of the nodes that we have already removed. So for example, there are first 10 here. We will just be removing all the first and first nodes that has equal to our num. Yeah, we'll just be removing the node that has a equal element value of our number that we have want to remove. So it will just count. And if that's true, which means that if we also have a value here, 10, 10, 10, we have already counted that 1, 3 here. So of course our counter would be equal to 3. And if that would be true, of course what we will be doing here is that while our current next is not equal to null, we will be going to the next position. So this means that as long as our current next, which for example, in the value of 10, 20, 30, 40, if this is our position, and I mean, if this is our position and our current next is pointing to null, is pointing to null, then that means that we will be stopping because we cannot already get any element value here, and we cannot compare that one here in um, our this iteration here. So we will be iterating to all the loops here as long as our current next is not equal to null. So if that is true, I mean, if our current node is not equal to null, that is true. If our current next is equal to the element number, of course, if our current if if our current next, which basically the position that we will be checking, because as what I have mentioned, we are just in the current position, but we cannot already go to the next element, to the current next. I mean, to the current next position null, because that would mean that we cannot already compare any node there because the value is null. What we'll be doing is, while the current next element is equal to the number, we will just be setting that. We will just be replacing. We will just be setting our temporary to the current next, which is basically our temporary is the number that we want to remove. And our current next, which is the next position, we will be setting that one to the next number that we want to remove. So this is the number that we want to remove, and the temporary next is the next to that number. So if we will be setting our current next, which is basically, for example, our 10 here is the current next, the 20 here is the temporary, and the temporary 20. So I will just be naming this one. This is the current next. And this would be our temporary, and this would be the temporary next. So if we have a position like this, 20, 30, so that means that we will be setting our current next, which is this one. We will be pointing this one to our temporary next, which is this one. So basically this already don't have any reference. If we will, I mean, if we are coming from the head, we cannot already refer here because we are already pointing our current next to our temporary next, which is basically the next one of this one. So after that one, we will be freeing our temporary. Bye bye temporary. And good job, we have already removed that node list. But there is a case. If our current next is equal to null, of course, if we have 10 here, I mean, if we have 20 here, and this is our temporary. If our current next is equal to null, which basically means if our current next, which will be the temporary, is equal to null, we will just be setting our tail to the current, which is this one. This is the current. This is the current, and the current next is the pointer. So we will just be setting our current to tail. So this would be our tail, and still we still have completed the iteration, and by that one we will return the value control, I mean our counter. This is a counter, so we will just be returning how many value we have removed. So after that one, our end contains here. Let's check how many minutes we are explaining ourselves. So in this one, in our contains int number. So we will just be iterating in our list here. Actually, I have made a different kind of iteration here, but don't worry. I can just set this one to while, but I'm just trying to experiment myself here. So counter 1 is equal to integer 1 is I have just set it as 1 because this means that okay. this will serve as our counter. So I am pretty sure that we will be going to the next loop. I'm sorry. So going next to our next function, which is the integer contains. So this basically means that it will return. We will input a specific number, and it will return how many instances we have. Okay, I'm sorry. In our contain function, it will return the position of the index. I mean, the position of our node and our linked list. So, for example, we in our linked list here, we have a linked list of a value of 10, 20, 30. So, if we will input in our function 20, it will return the second position. It will return 2 because 20 is our second position. And yeah, that's basically it. So of course, there will be constraints, and the constraints are if we don't have any, if we don't have any value that contains this specific number 20, of course we'll be returning 0. So we have just loop in our array here, and of course if this would work once, it will be added. It will be counted because if our current position element is equal to the number, it will return I. Oh, I think I have explained myself wrong here. Okay, so I'm sorry, it's my mistake, but okay, I see. So that means that if we have found our position, if we have found the number that is equal to the return, if we have found our element which is equal to the number that we are looking for, we will return the first one. But if not, we will be adding plus plus here, and we will just be iterating as long as the current, because the current is not equal to null. So this is basically the same. Current is not equal to null here. So as long as our current is not equal to null, because of course if this will be true, we cannot scan our current element, we cannot compare our current element to our number. So if this case would not be true, I will just be returning 1 because this is the first iteration here. And if that would be true, we will go to the second position because we are setting our current to current next. So this is the second position, and I plus plus, and yeah, I plus plus, and then in the next position, if this will become true, of course we are already in the second position, and it will return that number. It will return our counter. So I is our counter here. I will just be setting this one for readability purposes. Count plus plus. So in this one, in our counter, in our count, this will just be, let's say this will return the count of instances in the element number linked list. Okay. So this word in the let the remove all method having the method count. Okay. So in our function in count here, it will just return how many instances having the method. Okay. It will just return the count of the number of elements that is equal to the number that we have inserted in our parameter here. So of course we will just be setting our number here so that we will be able to count how many element of our nodes is equal to our number. So of course if the element of our node is equal Of course, so of course, if this would be true here, if our head element is equal to the number, of course we will be setting our count is equal to one already, and this is our current head roots. We have created a new node, which is we have pointed to our new node pointer, which will be pointing to our head. Head is also a pointer. And while if this is true, so this is not equal now, so that it would be more readable. So while our current next is not equal to null, of course, if our current next is not equal to null, which basically means that if we have a 10, 20, 30, and if we have already here, and our current next would be this one, which is equal to null, we will stop. But if still that was not the case, of course, we'll be checking if our current element, I mean, if our current next element is equal to the number, because since we have already checked the first element here, head is equal to number, we have already count one here, because if we will not go with this process, current next is not equal to our null. Of course, if we will get here and still we will move to the next current, of course, moving to the next current will put our position to the null position, and if we will be having this, implementation here, the current element will this will return false, and there might be chances that we will be returning random garbage value, and chances are we'll be adding count because the element is equal to the number. So we don't want that to happen. So of course, if that would not be true, we will just be going to our next node, which is we will which is in order to go there, we will be setting our current node, which is basically our head. I mean, if that would not be the head, that would be the depending on the position. So we'll be setting our current current node, which is the current node, to current next, so that we would go back here, and after that one, after all this process, we will just be returning how many counts we have made in our iterations here. So of course, after that one, we will just be going to our next explanation here, which is the entail, integer tail, which just basically returned. Okay, okay. So what we did here in our remove tail is, of course, if our index is equal to 0, in our remove tail, it will just return the position of the last element. I mean, the position of the last element, which is basically our last element. I mean, our last node, which is basically our tail. We will just be returning the value of that one. Return 0 until this is equal to. Okay. So we will just be returning the value of that one. So for example here, so what we did here is if our index is equal to 0, of course we don't have any node there. We will just be return 0. We'll just be returning 0. But if that's not true, of course we will just, since we will just be removing the tail, we will just return this function, which basically calls the global variable here. We can just use remove at here, remove at, because remove at was already in our higher was already in the top of our code here, but just to make sure, we'll just be using this pointer, this arrow pointer, so that everything should be working. So at our remove at, of course, the index is our last position, and at our remove at function, we will just remove the remove at a specific location, and our specific location is the index, which is the last function. So we will just be returning that one. And our remove at is a integer which will return the position of the index that we remove. So that would mean that we will be returning the index, which is basically our last position. So in our empty, we have just used a ternary operator here. If our index is equal to true, if is equal to 0, if that would be true, we will return true. If our index is not equal to 0, we will return false, because if our bool here is empty, that means that if this function here will just check if our linked list is empty. Wala akong sincere. If our linked list here is empty, it will return true, and if not, it will return false. So that basically means if our index is equal to 0, that means that yes, it's true, our linked list is empty, and if it will return false, of course, it is not equal to 0 on our index, and our linked list is not empty. Okay, so the void clear, we have not freed our element here, but we have just set it our head and tail to null, which is basically a bad idea. So the first thing that we will be doing here is I will be implementing the code, but since this is working, I think this should be fine. But we will just be moving next to our bool move. So in our bool move here, of course, we will just be swapping the position of the position 1 to position 2. For example, we will be swapping the position of the second element to our third element, or the second element, I mean the second node to our third node, or whatever node will it be. Of course, we'll be having a constraints here if our positions that we have given is less than or equal, I mean less than 1, which basically we don't have any position at that area, or if our position is greater than the index, which basically means that that value of our linked list is empty. So what we can do here is return false. But if our position is equal to so this one, we are checking if our position is already equal to our, I mean, if the position of the both linked lists is equal, we will be just returning true, because that means that the position that we are trying to swap has already the same value, so there's no point in swapping them. So the first thing that we have done here is we have created a new node here, and if our position is equal to 1, of course if our position is equal, if our first position is equal to 1, we will be our head is equal to the current next, which basically the second part, and also we will be doing a counter here. So this is 1, which basically means the position is this is our current position. So if our current position is less than the position, this should already be the second position. So less than, not less than. If our current position is less than than our position, so that means that if the x, which is 1, is less than the position 2, of course we will be setting our current node to current next, then current x plus plus, so that we would be able to go to the place where we want to swap, where we would be able to go to the position of our first position. So in this one, we have created a node to be moved to current next, which basically this one, and our current next node to be moved. We'll be setting our current next to the third position. because let's assume that this is the second position. So if we're pointing our current next to our third position, and after setting that one, our current next or third position, we will be setting our node previous. Will node previous is equal to head. So after that one, we have already found our first position. And for this one, if x is equal to 1, we have set it where x is equal to 1 here. And while x is less than the position minus 1 here, for example, 3 or 4 maybe, we will just be setting our previous position, which is basically means that the okay, we'll just be iterating until we found our next position, our next second position. So if that would be true, um, since we have inserted our position in our next here, in our node to be moved, our node to be moved is the number, I mean, is the node that we want to move. Yeah. So our node to be moved is the number that is the linked list that we want to be moved to our next to the given position. So our previous position, this one is the position of our first position, and our previous next, which is basically our second position, we will, I mean, our previous next, which basically our first position, we'll be setting that one to our previous move, previous to our first position. So if the position 2 is equal to the index, of course, if the position 2 is equal to the index, we will be setting our tail is equal to the node to be moved, because this is the second position, and we will be setting that one node to be moved. So tail would be the node to be moved because our position here is equal to the index, and then we will return true because it had been successful. Because there is no way that it would not become successful, because either it will return false here at the first test case, first constraint here. So I think I have already explained myself here. So yeah, that would be basically it.